Welcome to this session. Hope you have completed watching the previous videos and completed the discussion forum activities. If not, I would suggest you to do that before watching this video. In this presentation we will be discussing more on the steps in design process with an illustration exemplifying a building project. Then we will also be discussing about engineering economics and intellectual property. You will also be asked to complete the activities and post your response either in the YouTube comments section or in the discussion forum. Please don't forget to mention your student number while posting your answers. At the end of this presentation you will be able to understand design. Understand the application of the steps in design process. Let us recall from the previous presentation the steps that are involved in design process. They are: Step 1. Recognizing the need for a product or a service. Step 2. Problem definition and understanding. Step 3. Research and preparation. Steps 4 and 8. Conceptualization and presentation. Steps 5, 6, and 8. Synthesis, evaluation, and presentation. Steps 5 and 7. Synthesis and optimization. Now if you see, I have shown the steps 4 and 8, steps 5, 6 and 8 and steps 5 and 7 as a combined step. This is to show that these steps sometimes overlap and change their order depending on the project or the product that is being designed. To make it more clear, let us consider building project. In case of a building project, the tasks that must be accomplished are: 1. Recognizing the need for a building, that is the step 1 in the design process, that is, recognizing the need for a product or a service. 2. Define the usage of the building, that will be the step 2, which is problem definition and understanding. 3. Project planning, that will be the step 3, research and preparation. 4. Schematic design phase, that comprises of steps 4 and 8, conceptualization and presentation. Similarly, you will see 5. Design development phase, steps 5, 6, and 8, synthesis, evaluation, and presentation. 6. Construction documentation phase, steps 5 and 7, synthesis and optimization, and finally number 7, which is the construction administration phase. Some of the examples pertaining to step 1 of design process in building projects are: demographic change in a district. An existing building may need to be expanded to accommodate the increase in population of children between 6 and 12 years old, and that a factory needs to be expanded to increase production to meet the demand. The step 2 of the process is to define the usage of the building. This is the step where the team determines the types of activities that would take place in the building. For example, in the case of a new elementary school, the principal would forecast the number of students expected to enroll in the near future. The usage and activity data will help the architect determine the amount of area, square footage, needed to accommodate the client's projected need. The step 3 of the process is detailed project planning. In this step, the team selects potential sites for the new building by considering the factors such as environmental impact, archaeology impact, and traffic flow. It is also important to note that the architectural firm does not perform any design. Instead, they collaborate with structural engineers, mechanical engineers, electrical engineers, interior designers, drafters, and project managers to complete the project. The step 4 of the process is the schematic design phase. In this step, the architect consults with the client to fully understand the intended usage for the building and to obtain an approximate budget for the project. Through continuous communication with the client, the architect then narrows down the options to 1 or 2 designs. The design would show the layout of the space and rooms. The material type and the framing system also would be proposed at this stage. The step 5 of the process is the design development phase. In this step, that is, the design development phase, the architect continues to finalize the layout of the building. The structural engineer then begins to perform a preliminary design for the building. Preliminary designs of the HVAC, heating, ventilation, and air conditioning system will be done by the mechanical engineer, while the electric design is done by the electrical engineer. Next, the interior designer provides a preliminary design for the interior of the building. The step 6 of the process is the construction documentation phase. During this phase of the project, all of the detail work is done that include design specifications and drawings from the architect, civil, structural, mechanical and electrical engineers, and the interior designers. The step 7 of the process is the construction administration phase. Once the construction document is approved and a general contractor is selected, construction will commence. The general contractor will have a superintendent on site to manage the construction and its progress and coordinates all the subcontractors. Based on the preliminary design, the contractor will then provide a cost estimate for the project. Also note that many projects would require adjustment in design due to unforeseen matters. Sustainability in design is critical during the entire process. It is important to consider the link among Earth's finite resources, environmental, social, ethical, technical, and economical factors. Sustainability is design and development that meets the needs of the present without compromising the ability of future generations to meet their own needs. An engineer is expected to design and provide goods and services that increase the standard of living and advance health care, while addressing serious environmental and sustainability concerns. Now, let us do an activity. In this activity, you will read and understand the article on becoming part of the solution, The Engineer's Guide to Sustainable Development, authored by William Wallace. This article offers 5 issues that must be understood if engineers are to assume new responsibilities in sustainability. I want you list them all in the discussion forum, and from your opinion, identify the one that is critical and give reasons. Your response must be posted in the Blackboard discussion forum by creating a new thread. To understand economics in simple terms, consider designing a product that is too expensive to manufacture. Then it cannot be sold at a price that consumers can afford. Engineering economics poses numerous benefits because it allows those in industry to make strategic decisions for their companies. These subjects are essential for engineering economics because they provide the foundation for engineers to make good decisions. In the business environment, engineering economy enables engineers to consider all aspects of the investment from both the technical and financial viewpoints. Engineering economy furnishes several patterns of analysis to determine rate of return, annual costs, and payout periods, which all serve as bases for decision. The basis of engineering economics relies heavily on the time value of money. Let us go back to the example of the construction project. The reason why we are discussing bidding projects is because it is analogous to software engineering project, and it could be easily related to projects from other domain. The properties of materials such as density, ultimate strength, flexibility, Mach-inability, durability, thermal expansion, electrical and thermal conductivity, and resistance to corrosion are taken into account before starting to build. As we had discussed about material selection and properties, let us do this simple activity. I want you to define the important material properties that are listed below and classify them as electrical, mechanical, or thermal. 1. Electrical resistivity. 2. Density. 3. Modulus of elasticity. 4. Modulus of rigidity. 5. Tensile strength. 6. Modulus of toughness. 7. Compression strength. 8. Strength to weight ratio. 9. Thermal expansion. 10. Viscosity. As always, post your responses in the discussion forum by creating a new thread and quoting your student number in the subject line. As design process involve teams to accomplish them successfully, it is important for an engineering to be a team player. The common traits of a good team are shown here. 1. The project that is assigned to a team must have clear and realistic goals. These goals must be understood and accepted by all members of the team. 2. The team should be made up of individuals with complementary expertise, problem-solving skills, background, and talent. 3. The team must have a good leader. 4. The team leadership and the environment in which discussions take place should promote openness, respect, and honesty. 5. Team needs and goals should come before individual needs. A team with members who represent the following secondary roles tends to be very successful. Let us see the roles that a team will be comprised of: the organizer, the gatherer, the creator, the team worker, the motivator. The team worker, the solver, the evaluator, and the finalizer. Conflict resolution is a way for two or more parties to find a peaceful solution to a disagreement among them. The disagreement may be personal, financial, political, or emotional during a project cycle. When a dispute arises, often the best course of action is negotiation to resolve the disagreement. Conflict resolution is conceptualized as the methods and processes involved in facilitating the peaceful ending of conflict and retribution. The word conflict has a natural negative association of battling, shouting, blaming and arguing. This makes conflict seem like something to be avoided at all costs. However, conflict has a very positive side of debating, questioning, and challenging the status quo. If conflict is viewed as a simple incompatibility of concerns, then it is a rational matter of choosing an approach in a given situation. So we can control conflict through our choice of approach. According to the Thomas Kilmann model, we each have a natural approach to managing conflict. I immediately connected this to challenging coaching and how we each feel about challenging our coachees. Maybe we have a natural orientation to challenge as we do for conflict. The Thomas Kilmann model identifies two dimensions when choosing a course of action in a conflict situation. These are assertiveness and cooperativeness. Assertiveness is the degree to which you try to satisfy your own needs. Cooperativeness is the degree to which you try to satisfy the other person's concerns. From this come 5 conflict handling modes. Avoiding equals sidestepping the conflict. Accommodating equals trying to satisfy the other person's concerns at expense of your own. Compromising equals trying to find an acceptable settlement that only partially satisfies both people's concerns. Competing equals trying to satisfy your concerns at the expense of others. Collaborating equals trying to find a win-win solution which completely satisfies both people's concerns. Project scheduling involves creating a document, these days usually a digital document, that details the project timeline and the organizational resources required to complete each task. A schedule is a listing of a project's milestones, activities, and deliverables. Usually dependencies and resources are defined for each task. then start and finish dates are estimated from the resource allocation, budget, task duration, and scheduled events. Project scheduling is just as important as cost budgeting as it determines the timeline, resources needed, and reality of the delivery of the project. Project managers that have experience are better able to properly dictate the tasks, effort, and money required to complete a project. A Gantt chart is a project management tool assisting in the planning and scheduling of projects of all sizes, although they are particularly useful for simplifying complex projects. Evaluate alternatives by examining the benefits and drawbacks of each alternative. During the evaluation of alternatives, careful consideration is given to social, economic, and ecological factors that influence the predicted outcome. The process of analyzing and evaluating alternatives applies evaluation criteria to alternatives or options in a way that facilitates decision making. This may be a one-step or multi-step process, depending on the complexity of the alternatives and the decision. Evaluating alternative solutions involves analysis, discussion, and review. Iterative cycles of analysis are sometimes necessary. Supporting analyses, experimentation, prototyping, piloting, or simulations may be needed to substantiate scoring and conclusions. Evaluate alternatives by examining the benefits and drawbacks of each alternative. During the evaluation of alternatives, careful consideration is given to social, economic, and ecological factors that influence the predicted outcome. Encourage discussion and use visual aids to help explain alternatives. Brainstorming is a good technique for identifying alternatives. Making lists of possible combinations of actions can generate ideas that can be shaped into alternatives. Often this is best done with a small group of people with different perspectives, knowledge, and experience. Intellectual property, IP, is a category of property that includes intangible creations of the human intellect. There are many types of intellectual property, and some countries recognize more than others. The most well-known types are copyrights, patents, trademarks, and trade secrets. Intellectual property, IP, refers to the ownership of an idea or design by the person who came up with it. It is a term used in property law. It gives a person certain exclusive rights to a distinct type of creative design, meaning that nobody else can copy or reuse that creation without the owner's permission. A patent is an exclusive right granted for an invention, which is a product or a process that provides, in general, a new way of doing something, or offers a new technical solution to a problem. To get a patent, technical information about the invention must be disclosed to the public in a patent application. A patent is the granting of a property right by a sovereign authority to an inventor. This grant provides the inventor exclusive rights to the patented process, design, or invention for a designated period in exchange for a comprehensive disclosure of the invention. They are a form of incorporeal right. The three types of patents are utility patents, design patents, and plant patents. A utility patents protect the function of a composition, machine, or process. Trademarks are word, phrase, or symbol, which represent a company or product. They distinguish the products or services of one company or organization from those its competitors may provide. Some other examples of trademarks include acronyms, like NBC, IBM, and extend to slogans, stylized fonts, and even colors. Copyright is a type of intellectual property that gives its owner the exclusive right to make copies of a creative work, usually for a limited time. The creative work may be in a literary, artistic, educational, or musical form. With this, we come to an end of this presentation. Please complete the activities. Hope you have started doing the assignments. All the best. Bye for now, thank you.